Okay. So, thank you for the introduction. Thank you for letting us having this talk today. So, before we start, we give a short introduction. So, I introduce myself. My name is Christopher. I'm a security analyst in the Security Operations Center at Audi. And my background is mostly in software development and security in the automotive industry. And at the moment, I'm also working on a PhD thesis. So, yeah, that's about me.
Okay, and let me introduce myself. I'm a security engineer at Audi with more than 15 years experience in the automotive domain. Mostly I work in the IoT or embedded security, and that means network security for cars, that it's CAN, Ethernet, and also hardware security. That means more or less trying to close all the different debug interfaces on all the different ECUs we have inside the car, and also to define new technologies which is available on modern microcontrollers, modern microprocessors like HSMs, trust zones, and so on and so on. Together with Christopher, we teach automotive security in our company, and the idea behind this is the knowledge and the experience we have collected over the years to transfer to the new generation of security engineers. And some kind of fun fact, if I'm not trying to secure our cars, I really like to do something with my hands, and this picture shows me building a canoe. And the funny thing about this canoe is that I can go away from all the security stuff, and the really funny thing is that the only thing I built which can be used for transportation, which is immune against cyber hacking.
Okay, so before we dive into deeper, a short disclaimer. You all know how this works. We're here privately, so we represent our opinion, not the opinion of our employee. And if you have questions to products and anything, I'm sorry we can't answer them. But feel free to ask questions later. I hope there are some. So, question first, is anybody here working in the automotive industry besides the two of us? Okay, one person.
There's another one.
Sorry, are you working for Continental? No? Good, because we have them in the slides later. So Karsten will introduce the environment we're working in, and
one of the problems we have for the people which are not have the knowledge about automotive industry, the problem which needs to be understood is how automotive industry works. And this picture shows the Audi plant in Ingolstadt, and round about 75% of this area are more or less production facilities. And to understand automotive industry, what does it mean? It means that we have this production plant and we are feeding from one side material, steel, aluminum, whatever, and some ECUs into the factory. And then some robots with all the OT stuff, and together with the workers performing some kind of magic, and afterwards nice cars leaving the factories. And to be honest, even for us, with quite a lot of experience and a long time at Audi, even for us, it's to some extent it's a magic that the cars coming out of the production line. And if somebody of you is visiting Ingolstadt, take the time, take a tour. There are some tours available at the factory line. It's really impressive. And for me, this is some kind of combination of German engineering and modern technology. And this combination, that's what defines automotive industry, automotive technology.
Okay, so to give you a more in-depth look at what we're dealing with. So some of you might have heard of Audi and of other brands, Volkswagen, but it's not just the one company, because we all belong to Volkswagen, it's a bunch of companies. And so we call that slide sharing is a double-edged sword, because yeah, you have some advantages when you share stuff, but you also have disadvantages. And so what we're sharing is, from the IoT perspective, several platforms, so the software, hardware, components, and when it comes to IT and OT, we also do that. And yeah, but that also means if one of the suppliers, for example, is compromised, it also means it's a fair chance that that supplier also works for all the other brands, and everyone's affected. And to also give you a small in-depth look, so I collected this number. It's not to brag, it's just to give you an imagination of the IoT devices. So our company releases around 9 million devices every year.
You mean cars?
Cars, yeah. So for us, IoT at that point is a car. And so every year, that means if some vehicle is vulnerable to anything, we have, after 2 years, 18 millions and so on and so on. So it's quite a number. And we also did we achieved some stuff in the past, and Karsten will explain that to you.
Yeah, I think it's important to understand what we have achieved regarding security till now. And first of all, we have an established framework and an established architecture for building modern cars. And maybe you have heard about this eCube 1.2 architecture. Probably somebody of you have read something in the newspapers about this. But this framework means that we have adapted security technologies for the usage inside the car. And adapted means that these technologies are streamlined for the automotive usage. For instance, we have a special kind of key management system in order to put keys in our IoT devices inside the cars with a lot of different ECUs inside the cars. Then, of course, we have also some kind of we have reached some kind of external certification regarding the cybersecurity management system. And to some extent, to have this cybersecurity management system sounds like a lot of paperwork. And to be honest, it's really a lot of paperwork. But without this paperwork, we do not reach the homologation, and the homologation is needed in order to selling cars to the customer. So at the end of the day, we need to fulfill the ISO 21434. We need to fulfill the regulations from the UN ECE R155. And all this stuff is to some extent established, is working, is in place, and we have all the different processes which are needed in order to fulfill these requirements from the authorities in place. And to some extent, we have already reached the homologation for some cars, and it's quite important for us. And we also have established a training plan for all the different stakeholders in the development process for security functionalities inside the car, and to some extent also for the IT part.
Okay, so that was kind of the boring stuff. Let's get into...
But it's important.
Yeah, it's important, unfortunately. So what are we confronted lately? So if you're not working in the industry, it's hard to imagine what we're dealing with. And if it comes to laws and other stuff, so most of you know the GDPR, so data protection. But what we're dealing with is if you want to sell cars in different countries have different laws. And the US and China and South Korea, that's the examples we picked here, they were the first to really engage with these new laws. And it sometimes means we're not allowed to introduce certain hardware. For example, in China, you're not allowed to put certain encryption hardware there because I think they're afraid people can disassemble the car and build some messaging service for themselves. And we have software components that we're not allowed to. So that means we have to create different ECUs for the same car, different ECUs for different countries. If you look at attackers and criminals, I mean, we are hearing that a lot in the Troopers conference. Everyone's dealing with them. But it means we have huge challenges for our organization and for our processes. But the most important thing is we're talking about security monitoring today, and that also means we have to deal with new requirements towards security monitoring. But that's not the only thing we're dealing with.
The other thing we have quite a huge problem. There are quite a lot of different tools available on the, I call it the gray market. There are some fancy tools which can be used for some kind of legal stuff, because some of these tools solve real problems which to some extent difficult to handle with the official VW toolset. But there's a small line between legal activities and illegal activities. And for instance, this device, this DigiProc, is promoted as a system for speedometer repair. But at the end of the day, it means to adjust the mileage. The other ones in the left is used for teaching new key fobs for a car. Even this is, to some extent, a valid use case if somebody loses key. But in most cases, this toolset is used for handling stolen cars. And the other one in the bottom is used for modifying the diagnostic communication between some testers, even some official testers, and the car in order to enable some functions which normally are not enabled. And the problem we have, there are quite a lot of these persons on the gray market, and they have quite a lot of their own research and development infrastructure. They are to some extent quite motivated to develop new tools to overcome our protection mechanism. And at the end of the day, it's some kind of cat and mouse running between the OEM and these guys. And we are trying hard to ensure the security of our cars, and also, that's the important part, the security and the safety of our customers.
Okay, so we collected some recent events that happened, so that's why I asked about Continental, because it's on one of our slides. But that's stuff you're all dealing with at some regard. And so the question is, who of you is also working in a security operations center or is related to being an analyst? Okay, there's a couple. Okay, so you can relate to this. So if stuff like this happens, and most of the time, unfortunately, it's in the press before we know about, we get asked about it. And so if you see in the press like FBI joins investigation at Continental, and we have some managers at our company that like, oh, Continental, that has something to do with us, they all get nervous. And so what they usually do is someone shows up and it's like, oh, what's the impact on the stolen or leaked crypto? Or do we use infrastructure of this supplier? And how bad is it that the ECU was compromised, for example? And how would we prioritize the mitigation? And to be fair, it's like you have to tell me now situation. And to be fair, we can't tell at that moment, and that's okay. And so if we look at all the data sources that we have, and probably you all know the cycle, so we want to detect, analyze, mitigate, and learn from it. Today we are focusing on the analyze aspect and more on the impact analyze. And so we not only have the vehicle, we already mentioned that, we have the plant, we have IT services that are related to that, and we have to do security monitoring on all of this. And so...
And we have also the customers.
And we have customers, and we have social media, and if you had this experience, some of the hints we get they're happening on social media, and so that's something we also have to monitor. And I don't mean threat intelligence, I just mean customers, they're complaining or they're afraid their car was hacked, for example. And so we're diving into like the Vehicle Security Operations Center environment and the scope on impact.
Christopher, you have access to the vehicle operation centers. You have access to all this kind of information we have at our company. It couldn't be that hard to get the information and to get answers to our manager.
Yeah, well, unfortunately, it is. And so to show you what the day could look like of an analyst, we start with a small example. So we just assume we have some intrusion detection system, we have an alert on that system, and we have an analyst, and so he thinks, well, there's something malicious, no problem, I can look at this. And if I just look hard enough at the documentation that's available, and so no one here is working in the automotive industry except 2 people, but so that joke doesn't work that well, because the file formats we mentioned here, they're just awful. You can't read them, actually. You need a lot of, it's XML, most of it. And so it's really hard. And the problem is, if someone asks you, so there's a signal that's compromised, what's the impact of the signal? And we just look at a technical specification that says, well, for example, it's a TCP packet. Yeah, the specification says it goes from device 1 to device 2, the length and other metadata, but you don't know if is it bad, if it's some sort of malicious. And so in the end, and you can relate to that, if you don't know, you just send an email to everyone. It's like, does anybody know what the signal is for and what's the impact? And unfortunately, that happens more than we wanted to. But to give you a perspective, in this, like I said, in this company, in the group, there are several 100,000 employees. So we have several engineering departments and suppliers. So it's not like you could call one person and they know it. So that's a problem, fragmentation. Yeah, so we come back to that later. And so the next question is if there's just a way to express what an analyst is dealing with. And it's funny, I had a lightning talk a couple of months back at the university, and I wanted to do a joke. And because in academia we all love equations, so I created an equation that was sort of a joke, and the punchline worked. But afterwards, some people approached me and said, well, it was a joke, but actually it wasn't. It's a really good equation. And I showed it to Karsten, and he said, well, it's funny, but it's actually true. And so we worked on that. And so Karsten will introduce to you the analyst's frustration equation that we use for the rest of the presentation to get things going.
Yeah, and as Christopher said, was really impressed by the equation, but then okay, there's something wrong. No, we need to redefine this equation. And the idea, what we come out, is quite a simplified equation, which can be used to discuss the different problems we have, and also can be used for finding the points where we can optimize the incident handling process. At the end of the day, we would like to calculate the level of frustration, and the equation we come up is, okay, we have a sum of all the current active incidents, so it's just the sum, and then we have this fancy formula, and I will try to explain the different terms in this formula. Okay, we have this C, this means complexity. The term complexity is used to describe to some extent, okay, how complex is the system we are dealing with. Because we have built, as I mentioned in the beginning, we have quite a huge framework for security, and also this part, which security is used for which purpose, is an important term in the equation. What helps is, in order to minimize the frustration, is to have a good documentation. And then we have in the fraction, we have this A, automation. That means if there is no automation at all, 0, then you are lost completely. So that means we need a good level of automation in order to to keep the frustration level of the incident handlers at least to a normal level. And then we have the term, it's a little bit difficult to express, and I'm searching for a better approach, but the idea is to have a number which expresses how many areas are involved in the problem. If it's a pure IT problem, to some extent it's easy. If it's a pure embedded problem in the car in one ECU, it's also to some extent easy to handle. But if the problem is introduced in the production into one ECU, and this ECU is connected to the backend and exchanging data with the backend, we have 3 different parties involved in the problem, and then sending an email to the complete company, to the complete brand, means a lot of people, and finding the right information, it's even more complicated. And I have an idea for an extension for this formula. If we have time at the end, I can show you it is discussing this automation term.
Okay, but before we proceed, just a question. So just raise your hand. So who's working in IT? Okay, that's about half of the room. So who's working in IoT? Like 2 people, 3? And OT? Okay, so the OT guys, people, have you ever had like an incident or a subject where it wasn't clear if it's an IT or an OT issue? Okay, so what we try to express here, and that's why I picked the verses, because before you handle the problem at all, it's a fight like, it's your problem. No, it's your problem. No, it's not my problem. It's clearly an IoT problem. No, it's an OT problem. And so that's a lot of effort goes into that before you even start to handle the problem, and that's why we came up with that. But we have some more details later. And so I start with documentation. So documentation is boring, we all know that, but it's important. And so the problem we have in our industry, and maybe in other industries you have the same problem, we don't have that one magic format for documentation. So we have wikis, we have the Microsoft products, we have email, and if you're not in the automotive industry, so Autosar and Vector. So Vector is a company that is kind of the leader in the automotive industry, and so they have all this proprietary stuff, and so you can't approach that. And I see a lot of pictures. So the slides will be provided to you. You don't have to take pictures if you don't want to. Yeah, and so on the other hand, we heard it in an earlier talk it was the keynote where we heard about the badge that didn't work and the excuses and the supply chain. And so we also have this issue. So we have a supplier, we have contractors, we have subcontractors, subcontractors. And it's hard to find documentation, but now comes the worst part. We have something in our company or industry that's called multi-sourcing, which is, to be fair, it's valid to have that. So that means don't rely on just one supplier, but it also means you have different software, different hardware, and different documentation. And again, another supply chain that it's hard to follow. And so that's sometimes very frustrating. The next thing we have is automation. We skipped that because we have that in the end. And Karsten will now describe to you the complexity and security we have.
Yeah, I mean, we need to go a little bit deeper into this complexity and security topic. And first of all, we need to understand what automotive security really means. And in order to get a feeling about automotive security, let's take a picture from a modern car. It's just the latest electrical car, the Q6. But it's not a promotion event, so let's go deeper. It's a view inside the car, and this picture shows the so-called domain controllers. Domain controllers are more or less some kind of high-performance embedded devices which handles different domains. And domains, for instance, could be the infotainment part, could be the climatization and comfort function inside the car, could be the communication to the outside world, could be the fancy stuff like autonomous driving. And also we have an ECU for handling all the different data communication inside the car. So that's some kind of picture. Let's have a more abstract view on the architecture in modern cars. We have Ethernet backbone, it's the black line over there, which connects the different domain controllers. And in this case, we have 4 different HCPs for different domains. And below these domain controllers, in most cases, we have quite a lot of so-called sensor and actuator ECUs. And then we have some connectivity module, and this connectivity module handles the communication from the car to the outside world and back from the outside world to the car. And it means some CE devices, the backends, and even the car-to-car communication. Modern cars are able to communicate to each other and send some information like, okay, there's a problem on the street, there's a pothole over there, and then the other cars following the first one can adapt the driving behavior. And if we go deeper into the ECUs itself, we see a lot of complex software architecture containing different virtualization, different OSs, and all the other stuff, and a lot of applications are built around a quite complex web of, as you already said, suppliers, sub-suppliers, different software packages, and so on and so on. And automotive security means also to understand the idea of the main slogan of Troopers: make the world a safer place. And automotive security is handling road vehicles. And then I have a statement from Ross Anderson. I needed to read: security engineering is about building systems to remain dependable in the face of malice, error, or mischange. And in order to understand, you call it IoT device. Our IoT device is a car. And a car, it's up to 2 tons, driving up to 250 kilometers per hour, and you have persons inside the car. And if there's a problem, then you can kill people. So, and it's our motivation in order to make the world a safer place, to build safe and secure cars. And that's, in the modern world, it's not that easy as in the previous world.
Okay, and so before we go to the next slide, one thing that none of the manufacturers usually do is to provide you with numbers. And we wanted to give you an impression of what we're dealing with and to provide you with numbers. And so we can't give you the actual numbers, but we decided to do some ranges. But I think it's still impressive to hear about them. And so on the left-hand side, we have what we call IoT, but it's a vehicle. On the right side, you have IT, and I think IT is easier to grasp. But so let's focus on the vehicle for the moment. And so within the vehicle, we have several ECUs. And we have over 250 ECUs. And now the next thing is quite impressive. We have over okay, it's not easy to read. So 2 times 10. So we have a lot of streams, TCP and UDP. And if you look at the protocols we have an overview later on. So we have a lot of IP addresses, unicast and multicast, and we have a lot of signal types. A signal is a form of communication where you transport information. And in a vehicle, you have different types. So Ethernet is known, I guess, by all of you. We have something like a CAN bus, we have FlexRay, we have MOST and other stuff. And so we have more than 30,000 of these signal types. And on the right-hand side, it's your left, I think, yeah, on your left side. On our left side, your right side, we have IT services. And so we have several hundred IT services. We have smartphone apps. So if you're a customer of the Volkswagen Group, you know about some of the apps. We have a lot of services. We we called it entities in that case, so we have servers and cloud, and that's several thousand, and we have more than 1,000 suppliers, and yeah, and there's definitely like a number of suppliers we're not aware of because we're not in controlling or that sense. So we have to rely on data provided to us. So we can summarize that a vehicle is actually a quite huge network, and that has to be monitored.
So as you already said, inside the car we are using different protocols for communication. That's CAN, CAN-FD, FlexRay, MOST, and some others. We have a slide coming showing all the different protocols inside the car. But it's important to understand that we have quite a lot of external communication. It starts with the key fob. There's also there's some kind of communication for diagnostic purposes, and it's not only connecting a device. The device itself, the diagnostic device itself, communicates to some backend systems. Then we, as I already mentioned, a modern car is communicating to other cars, as I said, for providing the state of the road and so on. And we have quite a lot of communication to the internet. It's just via the mobile network, 5G, 4G, and then we have the connection via the mobile devices from the customer, via Bluetooth and WLAN, and then the devices itself are connected to the internet, and we have some kind of communication to the infrastructure, like traffic lights, for instance. And another aspect regarding communication is modern cars are able to communicate to the smart home. And the practical use case could be, okay, the electrical car is used as an energy storage for the house during the day, and at the night it gives back some energy for keeping the light on in the house. But the next day, if the car should be used, okay, there must be at least some kind of energy available in the car. So what I would like to say is there are quite a lot of different communication channels from the outside world into the car, and all of them could be used for some attacks, especially if the car is connected to the internet. And that means everybody from his home could try to connect to the car and start some kind of malicious activity. And in order to understand this complexity, we need to understand that we need crypto algorithms. We have different software with all the suppliers. We have also the different kind of communication which needs to be somehow processed and somehow handled inside the different ECUs and also handled on the different communication partners connected to the car. And let's have a short look on the different protocols which are used inside the car. We have Ethernet-based communication. We have the legacy communication via CAN, CAN-FD, and also FlexRay and MOST. And on top on these different basic communication protocols, we have a lot of different other protocols. Some of them more or less standard, like IP, TLS, HTTP, and so on and so on. But we have also quite a lot of proprietary automotive protocols which are used for some specific automotive use cases. And the same is valid for the wireless communication, which I have shown 2 slides before. The communication could be based on Bluetooth. Bluetooth Low Energy is also available in modern cars for some reasons. We have Ethernet, as a WLAN in the sense, and then we have also the communication via mobile network, like 5G, 4G. And again, on top of these different basic protocols, we have a lot of standard protocols and some kind of automotive specific protocols. And the same is valid to some extent for the IT world and the backend world.
Yeah, so the graphics we provided, it's just a collection we made. So it's not 100% complete, I'm sure, but just to give you an overview. And so I think for IT you can relate more. We just try to come up with all the different varieties that are available. So we use virtualization, we use cloud technology, we use content delivery networks, and just to give you an impression. So what challenges are we facing on a day-to-day basis? Like we said, we can't provide you with numbers, but so we try to come up with a graph with a percentage. I start with IT. So at the moment in IT, we have a lot of compromised suppliers, and if you're reading the news, you probably heard from some of them. Continental was one that's well known. We have a lot of vulnerabilities, and the second biggest part we have is malicious activity. And this malicious activity means it can be employees that do stuff like using private USB devices or connect their device to other devices they shouldn't do, but that also means misuse of back-end systems from criminals and stuff. And so that's what we're dealing at the moment and IoT.
And for the IoT side, it's clearly visible that most of the problems we have based on implementation for some crypto. The crypto itself, in most cases, it's fine, but the implementation could raise some problems. We have some kind of concept problems, but most of the problems we see in modern cars are software implementation problems. And my personal opinion that this high number, or this high percentage of problems is based on the complexity of the supply chain. Because, to be honest, nobody knows what's going on in some devices, because there are quite a lot of different software parts somehow collected on the supply chain from different suppliers with different experience. And in order to get all the different functionalities a modern car must provide, to some extent this approach is understandable, but it will raise in the future quite a lot of problems. We have a small part of hardware problems. This is obvious because a car is running, and it's also a specific problem for automotive. A normal car is used at least 10, 15, 20 years. And if there's a problem inside some kind of chips, then sometimes these problems will be detected and will be used by the criminals. So hopefully, we can solve the problem, the hardware problems with some software. In some cases, it's possible. Some cases, okay, there is a problem with the hardware. So, yep, and Christopher, we have processes, we have documentation, we have the VSOC, we are fulfilling the ISO. And to be honest, it could be not that hard to handle all these different events we have discussed.
So, well, I'm glad you asked. Unfortunately, no, but let's take a closer look. We have to speed up a little bit to stay in time. So I created this example, and on purpose I picked all, like, the most complex scenario that's possible. And we start on the left-hand side, so that's the vehicle. And just imagine it's one function in the vehicle that relies on a back-end system. So we go down. So we use hypervisors within the device, which means we have different operating systems on an ECU. If we go down the stack, we have communication. And for example, we use one bus system, the CAN bus, to transport the information. We use SecOC. Well, you don't know about this if you're not in the industry, but it's a framework to encrypt communication. And then we leave the car via a different ECU that has access to an LTE modem. And so at that point, we can access the IT infrastructure. And the next thing is we have DDoS protection. So if some of you use, for example, Cloudflare, that's just one example I picked, you have this random host name, and then probably you use like some sort of load balancing, and then you decide to go into the cloud, for example. And if you use Kubernetes and Docker, for example, to implement the one function. So everything is required to provide one function, keep that in mind. And so you saw this earlier on one slide. We just picked the 4 domains, cryptography, software libraries, suppliers, and communication. And the bad news is, if you followed us in the previous slides, that it doesn't mean that each of these is provided by one supplier. In the worst case, everything is provided by a different supplier, and we end up in this mess. And so it's just one function. I mentioned before in the numbers, so we have more than 250 services on the back end, and an ECU, what would you guess? An ECU has at least 100 functions. So that's very complex, and if you look at a vehicle security operations center, we have to monitor this end to end. So that's quite a challenge. And so how do we approach this challenge? Well, usually, if you have to do something manually, you do it once, you do it twice, you get annoyed if you have to do it a third time, and by the 4th time, you probably write a script to automate it. And so we thought about the equation again. So what can we actually do to lower our frustration? And so what we can do is we can increase automation, we can increase documentation, and we can try to get rid of the fighting between the IoT and IT department. Complexity sometimes you can't avoid, and security, we have to do a lot of stuff that we are bound to by law, so we can't do about that a lot anyway. And so that's what we can do. And one thing we tried is to create a model that represents the relationship between all of these components. And so that far, far galaxy away that you see right now on the screen, it just represents the vehicle communication. So all these dots, it's 500,000 nodes, represent just the vehicle and the relationships between each components. And so what you can do with that information is, if you have a relationship graph, you can do graph queries. And one thing you could do is you can visualize them easier. And one example could be this approach. So I can query this model and say, can you please tell me if there's a signal, who's using the signal, who's sending the signal, and who's kind of related to that signal? And can you please plot it in a graph that I can read? You can get something like this. And if you're interested in, it's at the bottom, that's created with WAV files. Check it out, it's quite awesome. And if you use Python and Jupyter notebooks, you can use it for free. Otherwise, you have to purchase a license. And so what are the challenges and opportunities with such a model? So the challenges, of course, is how to create such a model, how to keep it updated, what data sources can you use. So for that model, I used a lot of time, I wasted a lot of time in scanning or processing the proprietary formats that we have. But what are the opportunities? So you can add, like we said, metadata to that model. And for example, you can say that's a safety function, that's a safety signal. So if that's compromised, it's bad because it's related to self-driving, for example. And you can just query that, and that means you can do automation. What you can also do is you could check TCP dumps, for example, against it. You can query the overall model, and it just takes a couple of seconds, and that saves just a lot of time. And you can use it to train AI to some extent.
Wait a minute.
Yeah.
We had a lot of discussion regarding this tooling and this model, and I'm quite impressed about the work of Christopher. But the elephant in the room is AI. And the question I have to Christopher is, what do you think about AI? Does it make any sense to use AI in our environment?
Okay, good question. So I think a lot of you are involved with AI at some point. So if you just use Copilot or ChatGPT, or you have to work with it. So we just thought, well, you can't just throw the equation into AI and so to solve all the problems. And so we think it's a useful addition, but the user expectation, I don't know if you're among these users, but usually the user expectation is, I have some shitty input, I throw it at AI, and ta-da, I get the best thing back. Because AI is a black magic box that does stuff. In a worst case scenario, and probably you heard of it, shit in, shit out, if you put shit in, you probably get shit out. And so I think my personal opinion is AI is useful if you use it for the best purpose and not just like the solution for everything is AI. So why don't we just settle for like input decent data and be happy if you get like that's close to a unicorn, but it's better than
Nothing.
Better than nothing. So, and that's kind of a good approach. And so how we think we can leverage its potential is AI can help us if we have alerts and they approach and the analyst already processed similar alerts, we can train an AI, it helps. And one brilliant idea we saw at a different place was to throw documentation in. So we have a lot of documents, and if you just want to know, well, listen, what's the parameter of that device, for example, and it's written in a Word document, and I don't know where this document is, and it takes me a lot of time to find it. Probably if we use like AI to scan these documents like a bot, we can ask and hopefully get the answer.
Short question. Does the AI also collect the information from emails?
That's a good question. Well, and automation, yeah, like we said, automation could be good. And so we have this overview, and it's an extension to the one you saw before. And we think on the right-hand side where the analyst's work is happening, we can use AI to support the analyst, but I heard some consultants trying to advocate that AI can replace an analyst, and we heard it today and at the keynote. I think the human factor is still important, and you can't just replace it. And an AI, like we heard, has no doubt, and humans have doubt, and that's important. And so if we improve this, the life of an analyst could look like this. So we get an alert, and it's already calculating some stuff based on a data model or some impact scores. And the analyst is provided with data that the person can actually work with and not wasting days and weeks collecting the information, and knows who to approach to get it fixed and fix the problem. And yeah, so that's...
So I have to say thanks to two of my colleagues from the product security department, Jörg Herz and Kai Volkmar. Without their help, this presentation would not be possible. And then that means we have finished to some extent. Thank you for your attention. Enjoy the lunch afterwards. We are open to questions. If you have anything, then please raise your question. And I promised some extension to the formula. Because we have some time left, as I have seen. The problem with automation is if you have a good automation, you can speed up the work of the analyst. But the problem we have is the so-called vendor lock-in. If you stick on a specific vendor and this kind of automation tooling doesn't support a new problem, but you cannot modify this tooling because you have some kind of different contracts, or there is no possibility to script this engine and so on. Please keep in mind the vendor lock-in could kill your automation, and you are back to a huge problem. So that's all. Thanks a lot.
Thank you.
All right, thank you very much. Any questions? There's one.
Which kind of data do you have in your model? Is this just about the signals, or also, for example, which third-party libraries are used to construct a signal or to consume a signal?
That's a very good question. So it's not a complete model because it took a lot of time to get that small model running. But what I used in that was all the communication. So like the CPUs, the CPU cores involved in the communication, the software, but not the software libraries and versions, because I needed a different data source for that. So the data sources I had were just representing like the communication. But still, I think it's a time saver, because I was able to, for example, I wanted to know like what device is communicating with a different device with Ethernet, and it took me like 10 seconds to get that information. And before, it just took like weeks. And if even I found someone that was having that information. So yeah, I'm really willing to extend that model with software versions.
And to add something to this question, we are trying to build some kind of database which contains all the different suppliers and which software is used for which issue. It's still not yet available, but if this database is available, maybe you can use this database to extend your model.
And we have to be fair, so there are certain laws that force us to keep track of the software versions. Yeah, but like you said in the earlier slides, we have a lot of platforms and a lot of software and suppliers, so it's not always that easy to get that information. And some of the suppliers, and it's fair to save the intellectual property, they just provide us with already pre-compiled software, and we can just compile it into our software, and we don't know what libraries they used, because I'm quite surprised still SBOMs are still not a thing, and I just don't get it, because we have automation, we have CI/CDs, so why can't we just release a list of the used software versions? But yeah.
Yeah, I suppose it's this web of different suppliers and sub-suppliers and sub-suppliers. Yeah. And somewhere in this chain there's a break, and then you got lost about the library, whatever. Yeah. And so it's a constant fight with our suppliers. Okay, please provide us the information we need in order to fulfill all the different laws we need to fulfill at the end of the day.
You said you had problems with the battle between it's an IoT problem, it's an IT problem. Do you have also a problem with battle with, it's a problem with the suppliers, a problem with one supplier, with the other supplier, with a sub-supplier? Yeah. So you have also problems with that?
Yeah. Yeah, but what's quite interesting, some of the suppliers that have sub-suppliers sometimes don't know what their sub-suppliers are doing. So it's like the same constellation we're having, but with their own sub-suppliers. And so they're fighting like, it's your fault, no, it's your fault, no, it's your fault. Not even before they get the information to us. And what I experienced, which is very unfortunate, if we have a compromised supplier, and I know if you have made the same experience, they are, well, by law, they are forced to inform us as a customer that they have been hacked. And they have to provide this information also to some government authorities, yeah, thank you. But the first approach is always denial, and I think it's fair because their law department tells them to do that, I guess. And so, but that's a problem because it's already in the news, and it's so, yeah, you've been in the news. There's nothing. There's nothing. Okay, but are you affected? No. And so, yeah, but I can see you're already on the darknet. I can already buy your data. So, are you affected? No, we're not. And that's kind of a very frustrating conversation. And yeah, but I think it's how the law department works. Denial, 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 and then. But I have to keep up. There are some suppliers that are very, very good at this. They informed us in time. They are cooperative. So it's not like everyone does it, but unfortunately, more of the suppliers are try to denial until the last minute. That's a very unfortunate.
Yeah, also, and to be honest, I'm quite long in this business, and I have started, as you have seen on the first slides, 15 years ago roundabout. And the interaction between the tier one, also Audi in my case, and the tier ones has changed over the years, and even the quality of the exchange of information between the tier one and the OEM has changed over the year. And it has changed to a lower level, and I think this is also a problem. But to some extent, I understand the problem if I go in the shoes of the tier one, because they have to provide us with high quality software with a lot of different functions. You mentioned 100 functions per ECU. And it's a huge amount of work which needs to be done, and it's quite difficult. And on the other hand, they have only a limited set of experts on their own. So I think that's the problem. To build software for cars, again, in order to build safe cars, it's a difficult task, and not everybody can do this. It's just the easy problem.
And we have small suppliers, and probably you all made this experience. Not everyone has the money to afford like a security department. And so if there's a sub supplier, it's fair to assume that it's a very cheap supplier, and they're not earning a lot of money, which means they don't have a good security department. Even if they have a security department, some of them don't even have like a CISO or anything. And so I can't blame them, but on the other hand, well, then just don't sub-supply your supply chain. I mean, you get a lot of money, and so do your job.
Yeah, long story short, at the end of the day, you can trust your own software. It's easy.
Yeah. And
was another question?
Is another question? Oh yeah, in the back.
Ja, ist aber fast bei 100 Zeit.
What attacks do you think are most common? What attack types or distinct attacks in cars?
You mean for cars?
Yes.
To be honest, the problem with car hacks is that in most cases you have to look for hacks which return some money. And I think that's because the hackers or the dark side, they have also some idea. Okay, we need to earn some money, and most hacks are regarding immobilizer functionality, enabling functions without paying for them for the functions, and also adjust, for instance, the mileage. Also, in order to get the price higher of an old car. And I think the new challenge is to modify the state of change of the battery in order to if you would like to sell a car, and then the state of charge is whatever, 99%, it's fine, but in reality the state of charge is whatever, 75%, then increasing this state of charge is quite not successful, is quite useful in order to earn a higher money. Also again, follow the money, and then you find out which attacks are more probable, also which will more probably occur in the field.
So aftermarket attacks, right?
For instance. Yeah.
Thank you.
All right. Any more questions? Okay. The last one.
Thanks for your talk and insights. I'm from the OT side, so my question is, how do you handle the long life cycle of your IoT devices in terms of security, patch management?
Okay.
Sorry.
A really difficult question, and to be honest, difficult to answer.
You have 2 minutes.
I have a good answer, I think, which doesn't put us into a position where we lose our jobs, and give you an answer that you can work with. So I think at the moment we're at the place what's it called, Automotive, like Boeing and Airbus and all these companies, because they already have devices that are long-lasting, that's the right word, and they already solved some of these problems. For example, how can we sustain like a build chain for our software if it's based on Windows XP and we have like Windows, I don't know, 13 or 14, and XP is just not supported anymore. And we all have ARM chips, and XP doesn't run on ARM, so that's some of these problems. And they solved it quite nicely, I think. And that's a point where we are right now at the automotive industry. And I think we can just learn a lot of what they did, but I think it takes another couple of years until we figure out that it's something we have to do.
Yeah, I think the problem is it possible to take over the approach from the avionic industry to the automotive industry, and they will try to give a political answer. We are working on this topic. and maybe we can go deeper during lunchtime, because it's a really complicated problem, and I also could list a quite huge list of problems regarding the long lifetime of the ECUs for a car. And maybe we can discuss, because it's to some extent the OT world and the IoT world in the sense of a car is to some extent similar. The main difference is that the OT world, for instance, for a factory, it's more or less built once, and for a car is built 9 million per year. That's the difference. But the basic principles are more or less the same.
All right, thank you very much. And as they said, they are here on the venue, so feel free to approach them if you want to, or if you have any more questions.